In this video, I will be going over lesson 16, which is about the probabilities of compound events. So our first question here says a compound event is an event that is made up of blank. Which phrase correctly fills in the blank? So a compound event is any probability event that is where you're doing two or more things. So here, two or more simple events, which is a simple event is just like normal probability, which is what we were working with in Unit 3. Compound events, it's kind of like when we do two of those. So instead of picking like one marble, we would pick two marbles. Instead of rolling a dice one time, we would roll a dice two times. All right, our next question says, which events are compound events? Select two that apply. So remember, a compound is where we're doing two different things. So we're either rolling a dice and spinning a spinner, or we are going to be rolling a dice two times or drawing a card two times. We want to pick ones where we're doing two separate things. So the first one says rolling a dice that lands on one. Well, it can't be that one because that's only one event, right? Second one says rolling a dice that lands on a 2 or 6. Okay, keep that one up. The third one says drawing two cards that are both red. This one counts because we're drawing two cards, right? And the last one says drawing a card that is a spade. Well, we're only picking one there. So that means that B and C here are going to be those compound events because they're dealing with multiples, right? Rolling a dice and it could land on a 2 or 6. And then the third one here, which is talking about drawing those cards. Okay, so one thing I want to talk about, and this is something that you're going to want to write down because we're going to be using this for the rest of this unit, and that's where we're asked to solve or like to actually find the probability of something. When we're actually asked to find the probability of something or of a compound event, there's two key words that you need to look for, okay? And those keywords are or and, okay? Whenever you see the word or in a problem, that is telling you to add your probabilities together. So remember how I was saying that compound probabilities are two separate events, right? So that'd be something like probability of rolling a 6 and then probability of picking a blue marble. Those are two separate probabilities. So when we see the word or, that tells us to add those probabilities. When we see the word and, that tells us to multiply the probabilities. So again, having this written down somewhere is going to make solving all our future problems much, much easier. This question here says, which answer correctly describes how to find the probability of the following compound event? Rolling a dice that lands on an even number, 2, 4, or 6. Here's that word or, right? The word or is here. So or tells us to add our probabilities. And there are three separate events that are happening here. I have a probability of rolling a 2, rolling a 4, or rolling a 6, which means I have three different possible outcomes. So for this problem, I'm adding together three different probabilities because I could have three different outcomes. So I want to add the probabilities of rolling a 2, 4, and then a 6 together, okay? Our next question says that an experiment involves rolling a dice and drawing a card from a standard deck of 52 cards. What is the probability that the dice lands on a 4 and the card is a heart? So this is where, if you're not familiar with a deck of cards, you want to Google it. Because if you don't know how many hearts there are in a deck of cards, you won't be able to solve this problem, right? So I know that with the dice, only one out of those 6 numbers is a 4. I have the word and in the middle, which means I'm going to be multiplying. And for my which card is a heart, I know that that is 13 out of the 52 total. This simplifies to 1 over 4. Okay, so I have a 1 out of 4 chance because there's 4 different suits of drawing a heart. So I have 1 over 4. Now all I need to do is multiply these probabilities. And again, I'm multiplying them because this keyword here and tells me to multiply. Multiplying straight across the top gives us a 1. Straight across the bottom, 6 times 4 is 24. So the probability of me rolling a dice that lands on a 4 and drawing a card that is a heart is a 1 out of 24 chance. Our next question says, how many possible outcomes are there for rolling 3 dice? This question is a little bit different. So think about if I were to roll 1 dice, right? I'm rolling 3 dice here. So I have dice 1, I have dice 2, and my dice 3. I could get a 1, 1, and 1. I could roll the 1 on all of them. I could do 1, 1, 2. I could do 1, 1, 3. I could do 1, 1, 4, and so on, right? I could also do like 6, 6, 5. I could do 6, 6, 4, 6, 6, 3. There's a lot of them, right? So the easiest way to solve these problems is to take each event, see how many outcomes there are, and multiply them together. So if I go back to my dice 1, dice 2, and dice 3, right? For my first dice, I could roll 6 different numbers. For my second dice, I could roll 6 different numbers. And for my third dice, I could also roll 6 different numbers. So now let's multiply all of these together. So 6 times 6 is going to give me 36. I'm going to multiply that by 6. When I multiply these two together, I will get 216, which means that I have 216 different outcomes when I am rolling 3 dice. So if you ever are rolling 3 dice for a board game, whatever you roll, you had a 1 out of 216 chance of rolling that, which is kind of crazy when you think about it, because the order of the numbers can change a bunch. All right, next question. So this question here says, which answer correctly describes the probability of rolling a dice that lands on a number less than 7 and drawing a card that is red or black? Okay, well, if I think about it, a dice is numbered 1 through 6, right? And all of those are less than 7. So for my dice, I have a 100% chance of that happening. Then, if I'm drawing a card, the only 2 colors that are in a deck of cards are red and black, which means that both of those have a 100% chance of happening, which means that for this one, rolling a number less than 7 and drawing a card that's red or black, both of that is going to be certain because those are all of my different options that I could do. Our next question says, which answer correctly describes the probability of drawing a card that is black and a diamond and flipping a coin that lands on heads? Okay, so on this one here, the first part, let's focus on just the first part. So drawing a card that is black and a diamond. Well, here's where, if you're not familiar with a deck of cards, you want to have one pulled open on Google. Just type in deck of cards, go to images, and you'll see a bunch of them where it has all of them. You'll notice that diamonds are red. Diamonds are not black. They're the red suit. Well, they're not, red's not a suit, but they're the red color in your deck of cards, which means that it's impossible to ever pull a diamond that is also a black card. So for that alone, it's automatically going to be impossible because I could never do that unless I make my own deck of cards and do it that way. So the flipping a coin that lands on heads, that actually doesn't matter here because that first part is impossible. Regardless of whether or not I flip my coin and it lands on heads, that doesn't matter because I'm never going to be able to pull a black card that is also a diamond. All right, our last question here says, which answer correctly describes the probability of flipping a coin twice in a row and having the coin land on heads twice? Okay, so here I'm flipping 2 coins. I have my coin 1 and coin 2, okay? When I flip my first coin, I have a 1/2 chance of it landing on heads, and when I flip my second coin, I have that same 1/2 chance. So if I were to multiply these together, I would get 1/4. Now 1/4, obviously that's not certain, and that's clearly not impossible because it can happen. So even here means 50-50, and 1/4, that's not 50-50, right? That's a little bit less than that. So because it is less than that 50-50 chance, it is unlikely that it's going to happen. It's not never going to happen. It absolutely can, but the chances of it happening are going to be unlikely. All right, that is all I have for lesson 16. Please let me know if you have any questions.